Hello, today we are going to create this parts turning process using the EDGECAM 2020 CAM software. First, we have to open the EDGECAM 2020 Launchpad, and after that we are going to the managers, license manager, and we want to use the homework mode, so click this one in. OK, close it, and after that we have to reopen it. Okay, we are in homework mode, so after that we have to make our tool store. Go to the tool store and the tool store administrator, and we would like to create an empty tool store. Give its name, tool store, and create it. And after that we have to activate it. Left click on it, and after that make it active. And we can close it. If we want to use the models feature, which we have already defined in the inventor, we have to activate our EDGECAM link add-in in the tools, add-ins. We have to find the EDGECAM link, and you can see it's blocked at the moment. So take the tick off the blocked and take these ticks in, click OK. After that, we have to open our model. If we made our settings correctly, we can close the inventor and reopen it with our model. We can go to the add-ins and to the EDGECAM, and our model will be imported into the EDGECAM software. It asks if we want to run the software in homework mode. Yes, we would like to continue. And now our model is perfectly imported to the EDGECAM. So the first thing we have to do here is to fit a stock. Our stock's diameter is 30 millimeters. Our back face offset is should be about 20 millimeters, so our machine can grab on it. The front face offset is 1 millimeter. That's perfect for us, and the stock length is 56, calculated by these numbers. We can click OK, and we can see our stock on our part. Next step, we have to find the features of the model. So go on the find features. We are looking for turning features first. Find turn features. Only the front features. We need turn profiles, front face profiles, grooves and threads also. We have an undercut, but the EDGECAM recognizes this undercut as a groove, so it has to be ticked in. And we also have to edit our turn options, and we need this topic, include grooves in the turn profile, because we want to make this undercut during the finishing, and as I said before, our undercut is recognized as grooves in the EDGECAM. After that we can click OK and go on the mill part. We want to find milling features also, because we have a hole in it, but we are looking for only the vertical holes. That's the only thing what has to be clicked in, and after that we can click OK. Now we have a front face feature, front turn feature, a front turn groove, and a full front turn thread. But we don't need this groove because we want to make this undercut during the finishing, so just right click on this groove and delete it. And here is our perfect turning profile. After we found our features, we can go on the machining. We want to create a new sequence. We are choosing our machine, which is a sample lathe 2-axis with millimeter. Go on the next again and OK. So we have our part in the machine. Now we can go into the tool store. We have no tools in it, so we want to create a new one. Give it a description. It will be a roughing tool. Give a comment. I give its ISO code for it. It will have the number 1 turret position, and we have to click in the roughing. We can go on the geometry. We are giving its standard ISO code for it, defining it. I'm writing the same thing, just like we did it before at the command. After it, we have to give the node radius, which is 0.8, and the thickness, which is 3.87. These are all values from the catalogs. Right now we can go on the mounting, and we are given Z and X gauge. The Z gauge will be 30 millimeters, and the X gauge would be 100 millimeters. And then we are ready. Click OK. Now we have our first tool for the roughing. For the finishing, we can do it in the same way. I won't show this yet, but we can go on with our next tool, which would be an external thread tool. So go on it and go on the create. I'm giving the description threading. And it will be the comment 2. It will have the turret position number 4. Right, now we can go on the geometry. Our reach has to be deeper than our maximum in-feed depth. So at the moment, if it's 2, it will be fine for us. The included angle for ISO threads is 60 degrees. The nose radius is 0.17. For the thread pitch, we have to click in the ISO, and after that we can give our pitch, which is 1.5, and we can give our thickness 2, which is 3.47. Every values are from the catalogs. Our side angle is 90 degrees, which is correct. We are giving the length for it, which is 125, and we are giving the width too, which is 20, the depth, which is also 20, and our F distance, which is 20 minus the PDX value from the catalog. The PDX at the moment is 0.8 millimeters, so the F distance is 19.2 millimeters. Okay, we can go with the mounting. We are given a Z and an X gauge. Also, the Z gauge would be 30 millimeters and the X gauge would be 100 millimeters. And now we can go on. After we made our roughing and threading tool, let's make some drills, go on the hole, and we want to create a new tool. This tool would be a spot drill. I'm giving the description for it. Spot drill. Comment. Diameter 10. Its tourist position will be number 3. We can go on the geometry now. The diameter will be 10 millimeters. The tip angle will be 120. The flute length will be 20 millimeters. The value for the teeth per flutes is 2. We're giving it a length, which is 72, and the diameter, which is 10. Our values are from the catalogs, and for the mounting we only have to give a Z gauge, which is 100 millimeters. We can make all of our drills just like we made with our spot drill before. By this time I created all of the tools we would like to use. I created a finishing tool and also the tapping tool, the countersink and the drill. So let's start our machining. I'm choosing the roughing tool, click on the select and okay, see the parameters. Okay, now we can see if our parameters are correct here, just like in the tool store. Okay, we have our gauges also, which have, and we can go on the spindle. Here we are giving the maximum RPM, which is 3000 for us, and we also have to click in the CSS. And click OK. We want to do a finish turn. Select the turn profile. It would be this one. Start point is correct. Finish point is also correct too. For compensation, we need a path comp. That's correct. We don't need profile extension. Go on the tooling. For the feed rate, we need 0.28, and for the speed, we need 520. And we want to use our current tool, so we can click on OK. Okay, it's generated our toolpath, but it does not look the best, so double click on it and we can modify it. Okay, go to lead and links. For leading, we need 8 millimeters to start outside the stock, and for lead out, we need 90 degrees with the lead radius of 1, and we don't need the length. Let's see. Okay, it looks fine. It starts outside the stock and it leads out from the stock with the radius. That's correct for us. Now we can go on the rough turn. Select the turn profile. We are selecting this one. The start point is correct. The end point is correct too. We need a Z and an X offset with 0.6 millimeters. Also path composition, we want to ignore the undercuts, and our tool would go in a straight line here and won't do this undercut here, so our finishing tool can make that one. And here we have the cut increment. It's 1.6 millimeters. We want to use the current stock of the tooling. We want to use the current tool. We have the feed rate 0.25 and the speed of 510. Click OK, and it generated our toolpath. Double click into it. Almost everything looks fine, but go to the stock options and edit it, and we have if we have hot rolled steel as our stock, its tolerance is plus minus 0.5 millimeters, so we can give a stock offset of 0.5 millimeters. Okay, and our part isn't finishes. Our part isn't finished at the correct position. It has to finish a bit further, like here, so we can go into the lead in, lead out, and we are giving a profit extension to the end. It should be about 6 millimeters is enough for us. Let's see what it generated. Okay, it looks fine. We can go on with the finish turn. So after the roughing, we want to change our tool. So we want to move our tool to the tool change position. And we go to the tool store. No, we don't want to add a new tool, and don't use filters. We have our finishing tool here. Click on select. See if all the parameters are correct, which I think yes, we have the gauges too. And in the spindle, we have the max RPM of 3000, and we are giving the CSS in. Okay, and we can create our finish turn. Select the turn profile. It would be this one. Start position is correct, and the end position is correct too. We don't need offset, we don't need profile extension. For the tooling, we have the feed rate of 0.11 and the speed of 600. These are also values from the catalogs. We want to use our current tool, and click on OK. OK, it's generated a path. Just double click on it, and we have to modify a couple of settings. Here everything is correct. We can go into lead and links. For lead in, we need an angle of 45 degrees and the lead radius of 1 millimeter, and we don't need this length. And for lead out, a 90-degree angle will be perfect with a radius of 1, and we don't need length 2. Go into the control, and we want to edit our corners. On the drawing, we have break chamfers with 0.5 millimeter chamfers, and we don't want to include the first entity, so click on OK. And see our new toolpath, so we can see the lead-in is fine. It makes our chamfer and leads out perfectly. Yes, the only thing we have to modify is our profile extension for the end. We need about 2 millimeters just to finish a bit further than the end of our part. Okay, we have only one turning left here, which would be a threading. Just move to the tool change position. go to tool store. No, we don't want to add a new tool. Don't use filters and select the threading tool. And now let's see if all the parameters here are correct. Okay, we have the gauges too, and we have the spindle of 3000, but we also have to click in the CSS. Okay, we have our tool now, and we have to make a thread turn. Select the line near the star point. We want to find this line. Super. We need constant volume for the strategy. For output type, we need a single block cycle. Forward direction, okay. At the moment we don't need lead in and lead out. We have the total depth from the inventor. Sorry, we don't have it. This is 0.971. Okay, we have this cut increment for a while. For tuning, just have to select our tool again, and we give the lead for 1.5, and now it's generated our path, but it doesn't look the perfect, so double click on it. Let's see, in feed method, radial, okay, that's correct. Link in type, we need chase the boat, so we won't make a collision here. Approach angle would be 0, retract angle, we should use 20 degrees. For lead in, we need 1 millimeter, and for lead out, we don't need anything. Okay, it looks fine. Go on the depth. For save distance, I'm giving 0.2. For digression factor, it's 1.35 millimeters. In total depth, it's 0.971. For cut increment, we don't need anything right here. Number of passes from catalog, we need 6, and we need 1 spring cut also. And now let's see what toolpath we have made. Okay, it looks a lot better. It finishes outside our profile. That also looks pretty good. Leading looks also good. So save our project and see if our simulation is correct. Okay, fast forward. Okay, stop at collisions. Go to turn view and let's see it. Make the roughing, finishing. Oh, yes. Okay, right here we see we made a mistake before. In the finishing turn, we ignored the undercut, so we have to take the tick out of it. Okay, and let's see our simulation again. Okay, it made the undercut. Here comes the threading. And the threading looks fine too. Let's see the view comparison. The green means that it's on nominal size, just like on the drawing. The red means material is missing from here because of the break chamfer, but if we are looking at our drawing, we see there is a tolerance on this side of the material and also on this diameter. So let's fix this problem. Close the simulation and go back to the finish turn. And here, if we are going into this register, we can modify some things, but I'm taking this a bit further. And let's see. Now, if we are going down on the rows, we can see what parameter we are modifying at the moment. And first, we have to modify this part. Here, we are using constant offset. Now, at the moment, for here, we have a tolerance upper limit with 0.5 millimeters, and the lower limit is plus 0.2 millimeters. Now, the average of these two limits, the middle of it, is 0.35 millimeters, but in plus. But at the moment, we are on the negative side of the z-axis, so this positive tolerance will be a negative constant offset here, so we are given minus 0.35 millimeters, and we want to modify this part of this element of our part. Here we can use tolerance upper limit and tolerance lower limit. We have a diameter of 28 with the tolerance of D9. So our upper tolerance limit is minus 0.065, and for the tolerance lower limit we have minus 0.117. And it calculates our constant offset immediately. I click on OK, save it, and see our simulation again. I'm just fast forwarding to the end and see the view comparison. As you can see, we have red here, so this means material missing from here, so we are having a longer side here, and material also missing from here, so we can be sure that we are inside of our D9 tolerance. For the last machinings, we are going on with the drilling. So let's move our tool to change position and do our. And now click on the holes cycle. Select points. We only have one point. This is this one here. And now clearance value will be 2. Okay. Retract value will be 2 also. Level 0. Fine. Feet type per minute. Direction forward. Okay. Center pierce spot. We will do a spot drill with the diameter of 423. It's fine. In the tool store, we are using our spot drill. Selecting it, we will have the plunge feed of 0.16. Sorry, 24, and the speed of 160. It's stirred position is correct. For preparation, we are doing a countersink. We are doing this after the roughing. So first we are doing the roughing, and after that we are making the countersink. The diameter of this countersink will be 8.147. We calculated it before. And it's in 90 degree of angle. We are choosing our sinking tool, which would be a spud drill with a 90 degree tip angle. It will have the feed of 1.24 and the speed of 160. Position is correct. Okay, go on the roughing. We will do a back drill. Its depth is minus 22.4. The cut increment will be same as the diameter of our drill, and we are choosing our tool, the drill, select it. Its feed would be 0.25 and the speed will be 842. Okay, position is correct. And for the last, we are going on the finishing. We will make a tap. It will be rigged. We have to give the depth. On the drawing we have the depth of minus 12, but we are using a type C tapping tool, so we must add to the depth 3 times of the pitch of the value of the pitch, so it's 12 plus 3 times or 1.25, which means it would be minus 15.75 millimeter. It's not full depth. It's pitch, as I said, 1.25. Right-handed, okay, and we are choosing our tapping tool. Select it and let's see what we just made. Save our project. Go into the simulation. Stop at collision and see the whole process a bit slower. This was the finishing. Here comes the thread turning. Here came the countersink and tapping for the last, and I add moving to home position. And now our machining program is done. Thank you for your attention. I hope I could help you with the EDGECAM software. Goodbye.